A line segment has endpoints A, 2, 3, and B, -4, 2. Point C is on the x-axis. Determine the coordinates of point C so that line segment AC is perpendicular to line segment AB. Here we must determine the slope of line segment AB. To do this, we will use the slope formula. We can then determine the slope of the perpendicular line segment AC. To do this, we use the fact that the slope of a perpendicular line segment is the negative reciprocal. As an example, if the slope is 2/3, then the slope of a perpendicular line must be -3/2. We can then simply use this slope and points A and C to rearrange the slope formula to solve for the x-coordinate of point C. Note that since point C is on the x-axis, the y-coordinate must be 0. So point C has coordinates x, 0. Let's first plot the points. Point A at 2, 3, and point B at -4, 2. We have to first figure out the slope of line segment AB. This is going to be the change in the y-coordinates, 3 minus 2, divided by the change in the x-coordinates, 2 minus -4. This gives a slope for AB of 1/6. For point C, which we know must be on the x-axis at x, 0, we know that the slope must be the negative reciprocal of 1/6, which will be -6/1, or simply -6. We can substitute then this slope into the equation for the slope of a line. -6 is equal to 0 minus 3. Note this is the change in the y-coordinates, divided by x minus 2, the change in the x-coordinates. To solve for x here, we first must remove the fractions. Let's multiply both sides by x minus 2. Doing this, we end up with -6x plus 12 is equal to -3. Now we have to subtract 12 from both sides. This gives us -6x equals -15. And then to solve for x, we have to divide both sides by -6. This leaves x equals 5/2. We can then say that point C, which must be on the x-axis where y is equal to 0, has coordinates 5/2, 0.